Hey everyone, we're going to evaluate the given integral, and we're using our inverse substitution. So let me write this out again. So it's the integral of t to the fifth power divided by square root of t squared plus 2 dt. Now this, we're looking at the square root part, and it has the form here. So that's what we're going to use for our substitution. So we're going to let t equals square root of 2 tan theta. Remember, our a squared equals square root of equals 2. So a is just going to be square root of 2. So that's how these a's need to match up here. So whatever you have here, you take the square root of to get that. And we're on the interval from negative pi divided by 2 to pi divided by 2. So now let's take the let's take the derivative of t, and that's going to give you square root of 2 secant squared theta d theta. All right. Now, what we know, let's just look at this piece. Square root of t squared plus 2 is going to equal, and you just square this, so it's going to be 2 tan square root of theta plus 2. Factor out the 2. You get 2 times tan squared theta plus 1. And then that's where you're looking at this piece. So that's just going to be square root of 2 times the square root of secant squared of theta. So that equals square root of 2 and secant theta. You don't need to put the absolute value signs because secant is positive in quadrants 4 and 1, which is where we're restricted to because we're using inverse trig functions. So now we can do our substitution, and so I'm going to bring this down. This equals, bring this down here, the integral of t to the fifth. So this is going to be, let's write this down, square root of 2 to the fifth is going to be 4 square root of 2 tan to the fifth power of theta divided by, and we already know what this is, so that's given here. So that's square root of 2 secant theta times our dt, and so that's going to be square root of 2, just copying that down, secant squared theta d theta. Okay, simplifying that, let's see what crosses out. These two can cancel, so I can bring this guy out. So this is going to be 4 square root of 2, and then I still have tan to the fifth power. This one's going to cancel, and this will just be 1, because this, when you cancel that out, this is just going to be 1. So that's it right there. D theta. All right. So the way I'm going to write this is 4 square root of 2 integral. Now for tan squared, we have tan to the fifth. So I'm going to write this as tan to the fourth of theta times tan of theta. But tan squared is secant squared theta minus 1 squared. And then I still have my secant theta, and I have this additional tan of theta d theta. Now the reason I did that is now I need to use u substitution, because I'm going to let u equal secant of theta. Therefore, derivative of u equals secant theta tan theta d theta right here. So now I can use u substitution. So what we end up having is 4 square root of 2, the integral, and now I'm just looking at this. So that's going to be u squared minus 1 squared du. And if you work that out, that's going to be u to the 4th minus 2u plus 1 du. Now, let's go ahead and evaluate this. We're going to get 4 square root of 2 and take the antiderivative. So this is going to be 1/5 u to the 5th minus 2/3 u cubed plus u plus c. All right. If we simplify further, let's see, I'll use white. I'm going to multiply everything through by 15, because that's your common denominator here. So if I multiply everything through by 15, not the c, just this. So multiply everything through by 15, you'll get, let's see, 4 square root of 2 divided by 15 times, well, let's do it on the next sheet because I'm running out of room. So basically what you'll get is 4 square root of 2 divided by 15, and I'm going to factor out a u, and then I have 3u to the 4th minus 10u squared plus 15 plus c. Now, let's substitute back in our u. So our u was secant theta, and our if we substitute it back in, we can get, so I'm going to substitute in these u's. So I'm going to get 4 square root of 2 divided by 15 times, and this is just going to be, let me write it out. U was secant. So secant theta times 3 times secant to the 4th theta minus 10 secant squared of theta plus 15 plus c. Now, don't forget that we had, let's do our right triangle here and figure out what we're going to put for secant now, because we still got to get back to t. So remember, we let t equals square root of 2 tan of theta. So tan of theta equals t divided by square root of 2. Remember, tan is opposite. That's a right triangle. Opposite over adjacent. And when you do the Pythagorean theorem, the hypotenuse is going to be t squared plus 2. Now we can substitute in for our secant, because secant, remember, is secant of theta equals hypotenuse over adjacent. So secant of theta is going to be square root of t squared plus 2 divided by square root of 2. So now we can fill in all our secants. So our final answer is going to be, well, we can do some more here. 4 square root of 2 divided by 15 times square root of t squared plus 2 divided by square root of 2 times 3 times t squared plus 2 squared divided by 2 squared minus 10 times t squared plus 2 divided by 2 plus 15 plus c. All right, and then we can simplify further. And I have it in a different color now. So if you simplify it further, you get 4 divided by 15 square root of t squared plus 2 times 1/4, and then you'll have 3 times t to the 4th plus 4t squared plus 4 minus, I'm going to put all this together here, 20 t squared plus 2 plus 60, close all that up, plus c. And finally, you can simplify this because these 4's cancel as 1 divided by 15 square root of t squared plus 2 times 3t to the 4th minus 8t squared plus 32 plus c. And that's just multiplying all this out and collecting like terms. So you can try that to make sure I did it right. Thank you. Have a nice day. Bye-bye.